Let's solve another problem applying the second derivative test. So here's our example. Find and classify critical points of this function. F of xy is x cubed plus y cubed minus 12xy. So what do we have to do? Let us do as before. We want to start off by finding critical points. And for the critical points, we're going to take the partial derivatives and set them equal to 0. So the partial derivative of this with respect to x is going to be 3x squared plus 0. We treat y as a constant. So the derivative of negative 12xy with respect to x is negative 12y. The partial derivative of this with respect to y is 0 plus 3y squared. Treat x as a constant minus 12x. Okay, so the reason I'm doing this example here is that to kind of show that some of the different tricks that we might need to use in order to solve these systems of equations. So how does this one go? So 3x squared minus 12y is equal to 0. If we end up, we can move the 12y to the other side and divide by 3. And we get x squared is equal to 4y, which is equivalent to saying that y is equal to x squared over 4. So from the first equation, we know we have this relationship between x and y. So we haven't solved for like x is equal to this number, y is equal to this number yet. But we've got this relationship between x and y going on here. We haven't used our second equation. And so what we're going to do is that we're going to take this new relationship between x and y and substitute that into this equation here. So what would that give? Everywhere where we see a y, we'll put x squared over 4. So 3 times x squared over 4 quantity squared minus 12x is equal to 0. So now we have an equation that just has x in it. Okay, so what we're going to do here, let us think about how we can proceed. If I expand this out, this becomes 3 over 16 times x to the 4th minus 12x is equal to 0. And let me multiply both sides here by 16 over 3, just to make this a little bit cleaner. So if we multiply both sides by 16 over 3, we would get x to the 4th, and then 16 over 3 times 12 would be 64x. Is equal to 0. And this is going to factor as x times x cubed minus 64 is equal to 0. And we end up with 2 solutions here. So one solution is going to be when x is equal to 0. And the other solution, the only real solution of this is going to be x is equal to 4. So, okay, we figured out x is equal to 0 and x is equal to 4. Now, what are the corresponding y values? So, when x is equal to 0, we have y is equal to 0 squared over 4 is 0. So one point here is 0, 0. Now, when x is equal to 4, what is y? Y is 4 squared over 4. Y is equal to 4. And so that gives us a point of 4, 4. So there are 2 critical points here, 0, 0, and 4, 4. And so, by the way, these are the only allowable critical points. Sometimes people slip up here and say, oh, x can be 0 or 4, y can be 0 or 4. So in addition to having 0, 0, and 4, 0, some people add 0, 4, and 4, 0. But if you do 4, 0, for instance, that does not satisfy this equation here. 0 would equal 4 squared over 4. That doesn't work, so that's not a critical point. So these are our only 2 critical points. Once again, we have 2 critical points. So once again, let's make our list here. So we found 2 critical points, 0, 0, and 4, 4. And before we fill in the rest of this, let us do the second order partial derivatives. Okay, so our x derivative, our x f sub xx, will be 6x minus 0. F sub yy will be 6y minus 0. And our mixed f sub xy, second order partial derivative, will be, so we take the partial derivative fx, we get, take the partial derivative f sub x with respect to y, we get negative 12. And you can see for yourself Clairaut's theorem in action. We take the derivative of f sub y with respect to x, we also get negative 12. Okay, so now working with this table here, what do we have? F sub xy, that's a constant. That's always going to be negative 12 regardless of what critical point that we're dealing with. F sub xx, and we plug in 0 in here, we get 0. We plug in 0, 0 in there, we get 0. And then plugging in x and y or 4 into these will give us 24 in both of those cases. Okay, so now we just have to do d. Remember, d is fxx, fyy minus fxy squared. And what do we have for d? So 0 times 0 minus negative 12 squared is negative 144. 24 times 24 is 576 minus negative 12 squared is 432. So what are the types? The type here, let us, where did my second derivative test go? Right here. So in the first case, d here is negative, and so that is a saddle point. And in our second case, d is positive, where in these cases, f sub xx is positive, so this is a local min. Okay, so that is another example. Why did I do this one? It's very similar to the previous one, but there's just a little bit more going on in finding the critical point. So I want you to be aware that sometimes you have to do this kind of stuff. Okay, so maybe we can end right here with this first pre-class problem for this section. So find the critical points of this function, f of xy is x cubed minus 12x plus y squared, and then use the second derivative test to classify them as local min, local max, saddle point.